how we're doing it. I love how we're doing it. Everything is based on these, what is it? Based on these formulas. Now let's go to the last one. Let's go through the last one. It says, after the fully charged capacitor is disconnected, blah, 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 blah. Let's see what the question wants. Don't read too much of this. Find the new electric field. What is electric field? E across the capacitor. Then they say, does the capacitor discharge? Okay, so now the question wants the new electric field. Let's find that first. Let's find the new electric field. How do we find the electric field? It's E. Are we going to use this formula or we are going to use this one? Which one are we going to use? Well, we are not going to use this one because it's the one we just came from using. Okay, we just came from using this one when we were trying to find the maximum amount of charge. So we have to use this other one, okay? This is the other E we are going to use in this situation. We need sigma and mu zero. Mu zero we have, sigma do we have? No. So we have to find sigma first using this Q over A, because Q we have, so we can come here and say sigma is going to be equal to Q, and Q we got was Q max, so it's Q max over area, which is going to be, what is the Q max? With the maximum amount of charge, what did we get? It was 0.32 microcoulombs, which we can come and say it is 0.32 times 10 to the power of negative 6 coulombs divided by the area. Area, we found it to be, you multiply the two things, the dimensions, right? This thing is 2 centimeters by 3 centimeters. So you come and say 2 centimeters by 3 centimeters. It is 2.0 times 10 to the negative 2. That's what centimeters. Then you multiply by 3 centimeters times 10 to the negative 2 meters. Okay, that is 3 centimeters. We get these two. So you're going to put this in your calculator. We can put it in the calculator and get a solution. And the solution which we will get in this situation is going to be 5.3 times 10 to the negative 4 coulombs per square meter. So it's coulombs times 10 to the negative 4. You say coulombs per square meter, okay? Coulombs, you can write it as coulombs per square meter like this. Then I'm going to come and say, okay, this is going to be my sigma. It's coulombs for charge over square meters for area. Now I can come and see E is equal to sigma over mu naught, okay? And we saw from here, from the other, static electricity, that E is F over Q, which means that E is going to be newtons over coulombs. So we should get it as this units being newtons per coulomb. So anyway, we can come and say, what is my sigma? 5.3 times 10 to the negative 4 coulomb per square meter divided by, what is my mu naught? 8.85 times 10 to the what? What is it? It's times 10 to the negative 19, I think. Times 10 to the negative 12 coulomb squared per newton per meter. So times 10 to the negative 12 coulomb squared per newton per meter squared. So what is this going to be now? We can put it in the calculator. You say 5.3 exponent negative 4 divided by 8.85 exp negative 12. You must get an answer which is going to round off to 6.0 times 10 to the power of 7. And this is obviously newtons per coulomb. And this is going to be the new electric field. Okay, this is going to be the new electric field.